Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, in this session we are going to learn the one of the very important physical property, that is ductility. So let's start with a brief discussion over the ductility, and then we shall learn about the gradation of the ductility with respect to the periodic table. Friends, we all use many useful electronic appliances, whether it is a home appliances or any other machine. We all have seen some wires attached to these machines, whether it is a plug-in wire or the internal wiring. So, do you know how these wires are made of and which materials or substances used to make these wires? Well, the property which gives you all the answers is the ductility. So now the question arises, what is ductility? It is a physical property of element of being capable of sustaining large material reformation or drawing into wires. Well, in less technical term, we can say that property in which the element can be drawn into wires is the ductility. Also, ductility is a type of study, we call it a rheology, which is the study of how material deform or flow in response to the forces applied to it. So friends, this concept moves around the stress and the forces applied to the materials or the substance. Well, there are two basic type of deforming stress and forces applied to it. First is compressive strain and second is tensile stress. First one results in the malleability of the substance, and second is the tensile strength, which is a force pulling the two ends of the material away from each other. I have given you one very good example of a game, we call it a tug of war, which provides a very good example of tensile strength being applied to the rope. So as a result, the ductility then is a plastic deformation that occurs as a result of these type of strengths or stress, and the element with high ductility are able to draw into wires without breaking, and vice versa. So now friends, let's understand by the crystalline structure how the ductility property is utilized by the materials and how the wires are being created by the forces applied to it. Friends, I have taken an example of any crystal structure of any substance. This is crystal structure of any substance or element. So this is the structure before applying forces, and when the forces are applied, let this is be the upper layer and this is the lower layer, right? So when we apply a tensile stress or the forces in the opposite direction, what happens is when the upper layer will shift to the right side and the lower layer will be shifting to the left side, creating a cavity or the space for the upper layer. And the upper layer, when found get the cavity, it will be fixed or settle down in those cavities. So as a result, this new structure which will be created is like this. This is the lower layer which was shifted to the left side due to the forces applied, and this is the upper layer, settle down the space which was left by the lower layer. So this is the second phase after the forces applied. Now if we further apply the forces to the opposite direction, the same will happen. The lower layer will be shifting to the left and the upper layer will be shifting to the right side. Lower layer creating a cavity and upper layer filling those cavities, and will create a new shape, a deforming shape, which is like this. So as a result, we get more thin wires. It gives the shape of the wires. More we apply the stress, more thin wires we will get. So the basic force is the tensile stress, which is a force applied or pulling the two ends of material to the opposite sides away from each other. So friend, this is the concept of the ductility property. Now let's understand the ductility of elements. Before starting with the ductility of elements, let's understand the factors which the ductility depends on. Ductility depends on, first factor is the crystalline structure, that is crystal structure of the material, what kind of structure the material is having, and second, the temperature. For the first one, we shall know that when we talk about the elements, we talk about the metals and non-metals. And when we talk about the crystalline structure, crystal structure of metals, yes, we know that the metals are ductile and non-metals are non-ductile. That is, metals can be drawn into wires easily and non-metals cannot be drawn into wires just because of the crystal structure metals are having. That is, the non-metals are having a rigid crystal structure and the metals have somehow the movable, or the you can say is the metallic bond which has been there in the metals. That is, the high degree of ductility occurs due to the metallic bonds, that is, which are found mostly in the metals and leads to the common perception that the metals are ductile. Well, the second is the temperature. Higher be the temperature, more is the ductility of material, that is, more easy we can draw into wires. That is, more easily we can draw these materials into wires if the temperature is high. So now two questions arise. First is, why metals are ductile, and are metals which are ductile are also malleable? Giving the first one, why metals are ductile? Well, friends, the metal are ductile. The very basic answer is due to the metallic bond which they have in their molecular structure. How? As the valence electron, which are delocalized, that is, they are free to move around the outermost shell, share between many atoms of the element, which allows the metal to slide or pull without being getting any strong repulsing forces that would be come across the material to shatter when we apply the tensile strength. The ions facing each other for the repulsion. So what happen is, first is the metallic bond and second is the delocalized valence electrons. These are the two basic reasons of the metals which gives a property of ductility to the substance. Because of the non-attractive forces, that is the intermolecular forces, are very less as when we apply the tensile forces, which can easily make them away to each other, as there is no similar charges and facing ions are facing each other for the repulsion forces. And the second question is, are those metals which are ductile are also malleable? No. Metals that are ductile are not necessarily malleable. As a very common example difference between these two properties is lead. Basically, this is a very highly malleable substance, but it's not very highly ductile. As the reason is due to the crystal structure of this element. Basically, the crystal structure of these elements dictates how they will behave and deform under stress. So the answer to the second question is the crystalline structure of the metals or element, which will dictate how the metal will behave under such strain or stress, or you can also call it forces. So let's come to the periodic table. Now the arrangement of the metals and non-metals. We know that when we move from left to right, we move from metals to non-metals, and we move from top to bottom in a group. We move from lower metal property to the higher metallic property. So keeping this concept in mind, let's understand the variation of the ductility property by group and by period. So by period, when we move from left to right, the ductility property decreases just because we move from metals to non-metals. And when we move from top to bottom in a group, the ductility property of element increases as from top to bottom the metallic character increases. So I hope you have understood the basic concept of the ductility property and the gradation of this ductility property. So in next session we shall learn about the hardness of the element. What is hardness and why materials are hard, and how the material can be changed into soft. Thank you.